Right, we've got some grouped data here, and we want to turn it into a cumulative frequency table. This essentially means, cumulative means a running total. So cumulative frequency means a running total of the frequency. And this bit here helps us because this is everything that's up to 10. So it's these people between 0 and 10. But this one is everything up to 20. So it includes these 14 people between 10 and 20, but it also includes these 9 people. So actually I add them together and that's my running total. What I'll then do for m less than or equal to 30 is also include these 26 people. I'm going to add that on to give me 49. Now I'm going to include these 27 people, so that's going to be 76. Now I'm going to include these 25 people, that's going to be 101, and so on. 101, 123, 140, 150. If I get it working, I've got this one at the end, I've got the total number, I can be pretty sure that I've not made a mistake with my calculation. Okay, now it's asking me to draw the cumulative frequency graph. So the first thing to do is label my axes. I'm going to label this cumulative frequency. Maybe I should write it in full, but I think C.F is okay. And this one is M here, or the number of marks. Alrighty, so I'm going to start out with the x-axis. This is 0, and it's going up to 80. So I need to think about how I can fit 80 on. And then always a good idea is maybe to try 10 or something like that. A 5's going to be, I'm not going to fit it on, and 20 is going to fit it on in too much space. So let's see, 10, 20, 30, 40, and I can see that's halfway through. It's going to work, so I can now label this. I think I've made the diagram slightly smaller than it was in the original past paper to try and fit it onto one page. Okay, for cumulative frequency, the highest one needs to be 150, and I'm not gonna I can only just fit 80 in by going by 10, so I'm not gonna be able to do that. So it makes sense to go up in 20s, and that is gonna work. Let me try that one again. That was meant to be 140 and 160. Even though that's too large, we can then fit in 150. Okay, so what do I do now? Well, I actually plot. These are sort of my endpoints of my groups, but they become my x values for where I'm plotting. So I'm going to basically start from 0. Sometimes you see this as a first point on the cumulative frequency, sometimes not, but I think it is a good idea to put that in. And then I'm going up to 9 after 10. Now let's just look at this. This is worth 20, and it's equal to 5 little squares. And what that's going to mean is that 4 is equal to 1 square. So if I'm going up to 9, then it's going to be 2 and a bit squares. The next one I'm going up to 23, so it's going to be just under a square. I think I've just put it just over the square. Okay, that'll do. 30, I'm going up to 49, so it's going to be just under halfway through. 40 is 76, so that's going to be exactly here. 50 is 101. 60 against 123. 70 against 140. And then 80 against 150. That's going to be exactly there. You can join this up with each point by a ruler, and maybe that's the safest way of doing it, but I don't think it looks as nice, so I'm going to join it by hand, which is also absolutely fine. you. I just have to concentrate there. It's got to go through every point, but there we go. That's our cumulative frequency graph drawn. Okay, we need to use it now. So students are awarded gold, silver, bronze, or fail. The top 10% of the students gold, the next 60% silver, and the next 20% bronze. Well, I think it's worth just doing a little diagram to help us with this. We've got 10%, and then we've got 60%, and then we've got 20%, and that's going to leave 10% to fail, sadly. And what we're interested in is the lowest mark that silver is awarded for. So it's going to be here. It's going to be 30% of the way in. I.e., like if the number of people, 30% of 150. Now, 10% of 150 is 15, so 30% is 45, and we're interested in the 45th person. Okay, I hope that made sense. The way I originally did it is I found out what 10% was and worked out that that was 15, and so if I've got 150 here, it's going to be the 135th person as the start of silver, and then I worked out that 60% of 150 is 90, so then I did 135 minus 90, and that also gave me the 45th person. So I've done a bit more than I need to, but you know, as long as you can kind of do things like this, then that's what the question is looking for. So it's going to be the 45th person in. I'm going to draw a line in green with my ruler, so it's going to be just after the first square. Okay, now in this case, I can see that this is going up by 10, so actually each little square is worth 2, so it's going to be 28. And I believe the answer accepted anything between 28 and 32, which surprises me slightly because I think you could easily get something less than 28. But there we go. Finally, explain why the teacher's method will not necessarily award gold to exactly 10% of the students. Well, the key thing is, I'm going to bring out the mark scheme answer. The boundaries are set from approximations based on group data, not the actual scores obtained by the students. What does that mean? It means we've grouped the data. We don't know if actually, although 9 people got between 0 and 10, they could have all got 0, for example. And we're kind of assuming with this commutative frequency that there's been like a gradual increase over time. So it's like basically it's evenly distributed. That's sort of what we're assuming. We're definitely assuming it if we connect it with a straight line. But we don't know that. So when we award the top 10%, well, we're going to make the boundary something based on it going up in that way. But what if we had 15 people, but what if all of the people in the 60 to 70, all of them got 61? Well, we've set the boundary higher based on what we think the top 10% would be. So actually, it wouldn't be 10% in reality. At the end of the day, the key thing to know is whenever you have group frequency, you are estimating. You're estimating the mean if you calculate the mean. You're estimating raw data using this grouped data. It's useful because you can look at it and get a lot from it very quickly, but it does lose some accuracy. Whereas if you knew the actual scores, you could guarantee that you'd get 10%. Okay, but at the end of the day, something like this in words.